Okay, so this is our second or third lesson in acids, bases, and salts. The homework assignment was there. You should have checked your answers in Schoology against the review book answers. But if you did and had some difficulty with them, I'll review them quickly as we move on. So first question here. Number one, according to the Arrhenius theory, what does this mean? Well, the only ion that an acid will produce will be the hydrogen ion. The hydrogen ion of the hydronium ion, that's this right here. The hydrogen hydronium, that's what's happening. What's happening here is this water molecule is all by itself. Along comes a hydrogen ion which has no electrons. It wants one pair of electrons, 2 electrons. It sees those and it clamps on right there and it forms the hydronium ion. And that's why an Arrhenius acid will produce hydrogen ion as the only positive ion. The Arrhenius base, again, produces as the only negative ion the hydroxide ion. Number 3 talks about what an organic acid is. An organic acid also produces hydronium ion concentrations. Now the organic acid is shown in its functional group. You're going to have either one of these functional groups somehow. It's going to be written in one of the two ways. You're either going to have this on the end of the thing where you have the COOH bond there, where you have a double bond CO and then an OH on it, or you're going to have, I guess I can't move this, the COOH. That tells you the high organic acid. Number 4, aqueous solution substance that yields hydrogen ions, again, is going to be an acid. An acid. Well, if we look through these things, we're looking for an acid. Starts with an H. Well, none of these start with H, all right? But this one right here has the COOH, tells us we have an organic acid. So there's your answer, organic acid. Number 1 is an alcohol. It has a OH, but it's bonded to C's and H's. That's an organic functional group. Over here is your base, all right? That would produce the hydroxide ion, not the hydrogen ion. And KH, that is simply a salt. Number 5. Number 5 is asking, which of these is an electrolyte? You need to remember that an electrolyte is either an acid, a base, or a salt. An acid, a base, or a salt. Where an acid is a hydrogen and a nonmetal. That's what that stands for. Hydrogen and nonmetal. A base is a metal with a hydroxide ion. And then a salt is a cation and anion. Cations are generally metals and nonmetals. So you have a table K that lists your acids, table L that lists your bases, and then salts are you can find by having a cation and anion. So which of these is an electrolyte? Well, the first one here, that's glucose. That is not a salt, acid, or base. Second one is sucrose. That is not a salt, acid, or base. The third one has an OH on it. You might be tempted to think, oh, there's your answer, but no, it has carbons and hydrogens, so that makes it an organic compound. That's an alcohol. Right here, the COOH, there is your acid. It's got a COOH, there's your electrolyte. Number 6, which one of these which of the following has if 1 mole of each of the following substances were dissolved in 1 liter of water, which solution would contain the highest concentration of hydroxide ions? This question is asking you, which one's the base? Because it talks about the highest concentration of hydroxide ions. That's an indication you're looking for something with hydroxide ions. The only thing that can do that is the base, and that is a metal hydroxide. So you have sodium hydroxide. Number 7 is a similar question. This one's asking you, which one's an acid? Because it's asking, contains the highest concentration of hydronium ions this time. Well, you're not going to find an H3O plus or an H3O in the ion, in the compound, but you will find something that has a hydrogen and a nonmetal or has the COOH. And again, there's your COOH. That's just a salt, that's a salt, and that's a base. So the one that has the highest concentration of hydronium ions is the acid. Number 8, this is the bottom one, is the one you have, which is an electrolyte. Again, you're looking for an acid, a base, or a salt. That's an organic compound. Number 1 is an organic compound. Number 2 is an alcohol. Number 3 is a metal, and it's a hydroxide, so there is your answer. That's your base. Number 4 is simply sugar. Number 9, which one is classified as an Arrhenius base? It's something that has a hydroxide in it and also a metal. That negates this one because we have the CH3. That is not it. That is not a metal. But lithium is a metal, so number 2 is your answer, lithium hydroxide. Number 10, as 1 gram of sodium hydroxide dissolves in 100 grams of water, the conductivity is, well, sodium hydroxide is an electrolyte, and as you add more electrolyte into, or add some electrolyte into a water, the conductivity of the water will increase. Number 11 talks about the difference between a base and an acid, or an acid and a base. The acid will have more hydronium ion concentration. The base solution will have more hydroxide ion concentration. All right? So the solution of a base differs from a solution of an acid in that the base will have more hydroxide. The base will have hydroxide. The hydronium ion is when you have the acid. This talks about being a stronger acid versus a weaker acid. And this is the thing. This whole idea has to do with dissociation. If you look at the first one up here, this first one, HCl, HCl completely dissociates. And that's why there's a full arrow here. It produces all H pluses and Cl minuses. These H pluses, they unhook from the Cl minus. They all unhook, and they are the workers for the acid. Whereas this weak acid down here in the bottom, you see that the top arrow heading back towards the HC2H3O2 is larger than the other arrow. That's indicating that the most of the hydrogen atoms or hydrogen ions do not dissociate from the C2H3O2. They don't unhook. They stay coupled. So you end up with a lot more of this and less of the hydrogen ion. So therefore that makes it a weak acid. So the hydrochloric acid is stronger because hydrochloric acid has more hydrogen ions in solution. 13 is asking you again about the Arrhenius acid definition. Again, it's number 1. 14, I guess the bottom one is yours. Potassium hydroxide is classified as an Arrhenius acid, Arrhenius base because KOH contains not the potassium ions, but rather the hydroxide ions. That's the important part, the hydroxide ions. Number 15 is not multiple choice. This is asking you to name these acids and bases. I'll give you a moment to name these and see what you come up with. Use those nomenclature rules I showed you. How'd you do? H2S would be hydrosulfuric acid. HBr would be hydrobromic acid. Both of those are monatomic ions, one atom ion, the sulfur and the bromine. So they're going to have the hydro prefix and the ic acid suffix. LiOH and MgOH2, those are just simple. You can either name them by the base method or not understand that that is the same as the ionic nomenclature method. Number 16 says the student tests the conductivity of an unknown substance and determines it to be a good conductor of electricity. They say, oh, it must be an acid. What's wrong with that? Well, acids are not the only thing that are electrolytes. You also have to consider it being a base, or it could be a salt. So there's not enough evidence to warrant that conclusion. There's not enough evidence to prove that, yes, this is an acid, because it could also be a salt or a base. So the additional tests that you would do have to do with the things you're going to learn in the next lesson. But one of the things you might do is you could test its pH. If you know its pH is less than 7, you would know that it is an acid. If you know that its pH is greater than 7, you would know that it's a base. If its pH was 7 or right around neutral, then you might think this is a salt, and because of that, you could conclude that it's a salt because salts are generally neutral. So this brings up our functional definitions of acids and bases. A functional definition tells you something how it behaves. So the functional definitions of an acid and base are, first of all, you don't want to taste them in a lab, but dilute solutions of acids taste sour. For example, citric acid, lemon juice. Lemons taste sour, okay? Sour Patch Kids, they have citric acid, another organic acid on them. They taste sour. Acids will react with hydroxides to form water and a salt. That is called a neutralization reaction. They cancel one another out. You did this back in earth science. You reacted acid with a carbonate, namely limestone, which is calcium carbonate, and it produced bubbles, and those bubbles were carbon dioxide gas. Also produced some water and a salt. They will react with some metals, and they'll produce a different gas, and that gas is hydrogen, as well as a salt. Acids are electrolytes. Acids will change litmus red. Acids turn red. Acid turn red. And they also will react with other indicators. Now, bases, they taste bitter, but you don't want to taste them because most bases are poisonous. So don't taste too many bases. Bases will feel slippery because what they're doing is they're combining with the oils on your hand and producing soap. That's a organic reaction called saponification. Bases will react with acids, again, to produce water and salt. Again, your neutralization reaction. They are electrolytes. They will change litmus blue, bases blue, acid red, and then react with other indicators to change different colors. Again, this is the whole idea of a strong acid and base versus a weak acid or base. Strong will completely dissociate. Weak will only partially dissociate. You now want to do the Arrhenius worksheet. This should take you about 6 minutes. Number 1 is 2. Number 3 is 1. Number 3 is 2. Number 4, 1. Number 5, 1. Number 6, 2. Number 7, understand that the square brackets, they mean concentration. So the answer to number 7 is 4. Number 8, 1. Number 9, 1. Number 10, both pure water and 10th molar hydrochloric acid, both will have hydronium ions, number 1. Not to the same degree, but they will both contain them. So how'd you do? So now you have the electrolyte worksheet. That too should take you about 6 minutes. Give it a shot. Number 1, looking for something that conducts electricity. You're looking for either an acid, base, or a salt, and your answer is number 4. This here shows you an electrolyte, an apparatus that determines the conductivity. You'll see this occasionally. The aqueous solution must contain an electrolyte. That's number 4. Number 3, you're looking for something that is soluble. The most soluble, that is 1. Number 4, again, you're looking for something the most soluble. Number 2. Number 5, best conductor will be the greatest concentration of the best electrolyte. Number 4. Number 6 is an organic reaction. You can skip that. Number 7, electrolyte because they conducts electricity. Number 3. Number 8, HNO3, will conduct electricity. It is an electrolyte. Number 9, the non-electrolyte is sugar, 1. Number 10, formula represents an electrolyte, either an acid, a base, or a salt. Number 3. This brings up pH. pH is the measurement of the concentration of hydrogen ion concentration in a logarithmic scale. It's not important to understand how it's done, just that it is done. At this point, we will do the acid properties lab.